comparison of two or more quantities. They're separated by a colon, and it's said to be one quantity to another. So if there are 80 girls and 100 boys at a disco, write this as a ratio of boys to girls. Now the order is really important. They've started off with boys, so we need to focus on how many boys there were. As you can see, I've written boys first, then the colon, then girls afterwards. So if there were 100 boys, we'd write 100, and then girls, there were 80. So it's 100 ... 80. You may be asked to simplify that later, but we'll just leave it as 100 to 80 for now. As I've said here, the order is really important. If writing quantities in a ratio, they should be in the same unit in order to be able to compare them. So a question may ask for you to write something as one ratio to another, but if they're asking you to compare them somehow, you have to change the units. So we've got 1 kilogram of flour and every 300 grams of butter. So 1 kilogram of flour and 300 grams of butter. In this case, or in any case, it's always easier to change them to be both of them to be the smaller of the units, which in this case would be grams. So we're going to change them both to be grams. This one's obviously already grams, so that would just be 300. And we know that 1 kilogram is 1,000 grams, so this would be 1,000. So 1,000 to 300. There could be 3 quantities that you compare. It's no different in the way we do it. You'll just have 3 values, all separated by colons. And again, the order is important. We just have to make sure they are in the correct order. So Sarah, Jennifer, and Shelby shared some candy. They're allowed to have the candy in the ratio of the number of letters in their name. So Sarah would have 1, 2, 3, 4, 5. Jennifer 1, 2, 3, 4, 5, 6, 7, 8. And Shelby 1, 2, 3, 4, 5, 6. The values should also be written as a whole number, so if they're not, we need to change them to be a whole number. So the recipe calls for 1.5 cups of flour and 2 eggs. So here we need to change the 1.5 cups into whole numbers. You've got a couple of choices here. Because we've got 1.5, we know that means 1.5. To make a half a whole number, we can just times it by 2, so we would get 3. In that case, we would need to make sure we're doing the same to both sides. So if we multiply the left hand side by 2, we would now have 3 cups, and the right hand side would be, I apologize, 4 eggs, because we've multiplied them by 2. Now, it's not always as easy. In this case, we could easily multiply it by 2 because it was a half. However, to get rid of any decimal value, we know that we can multiply it by 10. So our other option could have been to multiply by 10. So we've gone from 1.5 cups to 15 cups. And therefore we would do the same here. We would multiply by 10, so that would be 20 eggs. Either way, we just need to make sure that these numbers in these ratios are whole numbers. So the different ways of writing ratio statements. So a shop has 8 customers, 6 of them girls and 2 of them are boys. So as you can see here, we've got girls to boys, which would be 6 to 2, boys to girls, obviously the different order. But we could equally say girls to the total number of people. So we know that there are 6 girls and 8 people. Boys to the total number of people, 2 to 8, and so on and so forth. So you just have to be aware that there are different ways of writing ratios. What's the ratio of policemen to ballerinas? So they're sneaky here because they've got the pictures of the ballerinas on the left and the policemen actually on the right. So we've got 3 policemen and 5 ballerinas or ballet dancers. Apples to bananas, we've got 1, 2, 3, 4, 5, 6, 7, 8 apples. Oops. 8 apples and 4 bananas. And we've got 4 ice creams and 6 pieces of chocolate. Write some ratio statements for the following. We could have 6 glasses, 4 flowers, 5 hats. That's a really boring one. We could have 4 flowers to 15. Oh, I apologize. To 15 objects. Okay, so that's the number of flowers to the number of objects in total. Different ways of writing them. You can choose what you would like. Similarly with this page here. Now, simplifying ratios. In many cases, we'll be asked to simplify the ratios. We do this in a similar way to simplifying fractions, and in fact, you can often use your fraction button on your calculator, this one here, sorry, so this one here, you can use that to help you. So if we have, so what we're trying to do is we're trying to find a number that divides into both 15 and 25. Now I know that I can divide that number by 5 and this number by 5. So 15 divided by 5 gives me 3, and 25 divided by 5 gives me 5. Double check that that's as low as it can go. In this case we can see that is true. Let me just show you on the calculator. So I would write 15 on the top and 25 on the bottom, press equals, and we can say 3, 5. Don't write it as a fraction, but that just helps you there. 12, 3 and 9. So with this time we've got 3 numbers. Our number that we divide by has to go into all 3 of them, and I know that all 3 of them can be divided by 3. So 12 divided by 3 is 4, 3 divided by 3 is 1, and 9 divided by 3 is 3. 10 to 4, and they can both be divided by 2. So that's 5 to 2. So here's some examples. Perhaps pause the video now and you can put the answers, check the answers afterwards. Okay, so there are the answers there. You'll note that D cannot be simplified. No numbers go into 11, 3 and 12.